I'm Murray Oldfield. I'm a technology architect at InterSystems. So whether you've moved to virtualization already or you're planning on moving, this session is going to be about the pros and cons of virtualization, but really we're going to also be looking at the best practices and the best ways and some of the best things you can do, and really to answer some of the common questions I see from customers. I spend a lot of my time talking to CIOs and tech folks, and some of them are just moving to virtualization to begin with, although really today most people are there already. Or they're moving their tier 1 databases. They might have some other stuff on virtualization, but they really haven't got around to the database side of things. Or we just might be trying to solve a performance issue, and I'm helping them with capacity planning and why is their system not behaving as it should be? Because really today, 5 years ago I was doing these presentations about why you should virtualize, and when you ask people around the room who's running like VMware, you might get one or two hands, because really with databases there was a sort of a slow progression, where today InterSystems outside the US, we have an EHR application called TrackCare. We also sell HealthShare, and really the default for those deployments is virtualized. So it's like a no-brainer now. There are corner cases, which we'll talk about, where we choose not to virtualize, or we choose not to virtualize part of the solution, and I'll go through those. So virtualization has been around forever, and I like to tell people that I started on virtualized systems in the 70s. It was the late 70s, but systems have always been virtualized. We're abstracting the operating system away from the hardware. Now, back in the day it was mainframes, and we still have a lot of customers on AIX, for example, running on Power. And when I talk to them, AIX, their container is an LPAR, or and when I talk, or it used to be called an LPAR, it's now called something else, which Power VM, I think. I'm showing my age by forgetting things. So when I talk to them, though, when they talk about the virtual machines, they actually call them hosts. For them, virtualization is just normal. So this is not new. Now, the new kid on the block, and albeit since the turn of the century, is the x86 virtualization. That's where pretty much everybody seems to be. And if they're not there already, they're moving off Itanium, or they're moving, there's a drift even off the Power down to the x86, just because it's commodity, it's cheaper, and everybody else is doing it. So you get great support. The other sort of virtualization, which I'm not going to talk about, but is sort of implied in some of this, is the container stuff and Docker and the cloud. And there's been other sessions about that at this global summit. So we probably missed them, but if you go back and look at the recordings. But a lot of the same rules apply. A virtual machine on AWS is just a virtual machine. A lot of the best practices we apply to something you've got on premises still apply up in the cloud. So you can take a fair bit away as far as the best practices go. I'd like to just make the point that we've always supported virtualization for cache and for the data platforms. We put our systems out and we support them on a processor and an operating system. So x86 with Red Hat, Power with AIX. The fact that there's a hypervisor or some sort of virtualization layer in between doesn't actually stop us supporting it. And the only, if we do find situations where the virtualization is thought to be the cause of the problem, then we'll deal with that. So you have a problem with cache, you call the WRC, they'll help you solve your problem. It doesn't really matter as long as you're on a supported platform. So this picture is a representation of really what we call the cookie cutter virtualization. And this is what we give customers for TrackCare outside the US. So this is an EHR system, a bit like Epics or Allscripts or what the VA runs, for example. So for big hospital deployments, and like I said, for big hospital deployments, even for very large hospitals, we still do our first thoughts are it'll be virtualized, and then maybe reasons why we don't virtualize it. So what you see in the picture there is some number of hosts, 1, 2, n in a cluster. They're going to need to share the storage because one of the great features of virtualization is this ability to move your VMs around, to do vMotion. So if I move a VM from host 1 to host 2, it still has to be able to see the data. And really, a VM is just a bunch of files. So you still have to be able to see those files no matter which host you're on. So you have some sort of shared storage. Typically, for the last 5 years or more, that's a shared storage array, whether it's all flash or just EMC VNX or something else. But it has storage controller, cache, some number of disks, and they're laid out typically in LUNs, disk groups, and you have to do some thinking around that. Do I want to put my database on, RAID 1 on my high performance disks? Do I want to put my test and train on some spinning disk, or have I got a hybrid array? So there's all sorts of things going on. But the very simple picture is some hosts, some VMs, typically running vSphere, and shared storage. Now where we're going today is things are changing again. And I gave a presentation yesterday afternoon on hyperconverged. So hyperconverged is nearly the same picture, except now we've got software-defined storage. So the differences between the two pictures are the storage array at the bottom. So instead of having your disks out in racks, in trays, in your storage array, now the disks are brought up into the machine. And there's a few reasons for doing that. One is that you get much better performance. We're moving the storage closer to where the processing happens. The way we configure these things is by using all flash. So we're using much faster storage. So this might be, for example, Dell has a server called R730XD. So why is that different than like other servers? It's different because it's still a 2-processor server. It's a commodity server, but it's got 24 drive bays in the front. And some number of those drive bays connect to the PCI bus, which is much faster than the normal connections. So that uses NVMe. So you can get very, very fast performance from them. And then the other disks may be a SATA disk, but they're all flash as well. So we're getting great performance. The other difference with this is it's software-defined storage. So the storage is being managed by the hypervisor. So out in the solution exchange, there's the guys from Nutanix. This is pretty much a picture. I'm sure they've got better pictures than I do, but this is pretty much a picture of what they're selling and this idea. The other difference here is that if I want to add storage, I add a host. They do have storage-only options, but essentially the basic building blocks are hosts. I add a host with some storage in it. I need more storage, or I might need more compute. I add another one. And so it grows horizontally. And that's, as we come down to the best practices, you'll see why that might be important as well. The other thing with this, and a lot of my presentation yesterday was about that, was because the storage is per host, the way it's written is different as well. It's always written to at least 2 places. If we wrote all our data to host 1 because our VM was on host 1, what happens if host 1 fails or is taken out for maintenance, or one of the disks in the disk group fails? Well, your data has to be somewhere else. So just like a shared storage array, the VM could go and look elsewhere. So that's all managed by the storage. Okay, so this is the pros and cons session, and to be honest, I had to sort of stretch to get some cons. There are some though. Very small solutions, and I'll talk about those in a sec. If you have very high or unbalanced resource requirements, what we see when we deploy TrackCare, and I know that Epic does this as well, they deploy on virtualized platforms, and there's nothing wrong with having a VM using all the cores in your host. You can make a VM as big as a host is. So if your host is 44 cores, you can have a 44-core VM. Why might you do that? where you're taking advantage of the things the hypervisor gives you, like the HA and the management and so on. So there's no reason just because a VM is big not to deploy it on virtualization. But I'll show you perhaps reasons not to as well. If you have very low latency, and really we don't see this with cache databases, it's more your high frequency trading applications and so on. But there are some, the hypervisor adds a very tiny amount of overhead, just about unmeasurable. When we're speccing between bare metal and virtualization, we use the same calculations. We don't. That's not a reason for vCPU or CPU to be different. If you have specialized hardware, does anybody think of any specialized hardware that doesn't run on virtual VMs? There's a koala bear if you can think of one. I think we've all probably seen them, yeah? Pardon? Oh, yeah. Well, yeah. Apart from the operating systems not supported, is there any particular hardware you can think of that doesn't? Yes?
A mouse.
Yep, that's one. Anybody got another one?
Sorry.
I don't know if a mouse can actually.
And I'm just
tape. Everybody uses tape backup, but you can't virtualize that. Usually that's on a media server, that's standalone. So there are sort of like things you've got to take into consideration. Nowadays we're moving to secondary storage. This idea, the hyperconverged thing I showed you, they're using that for what they call secondary storage as well. So backups for cold storage, for doing test and dev and zero-byte clones. So I'm talking a whole lot of buzzwords now, so I've got to calm down. I've had too many coffees this morning. But layer 8 issues, so the TCP/IP stack goes up to layer 7. Layer 8 is us, the humans, and we'll talk about why they might be reasons not to virtualize. Okay, so here's the small case. Very small solutions, so we've got 2 hosts. We sell track care to very big customers, whole countries. But we also sell, very small implementations, like to a clinic in China that might have 10 or 15 users. And there's a bar that's set, like an entry level as far as virtualization goes. You need a minimum number of hosts for availability. You need shared storage, whether it's HCI or whether it's a shared storage array. You need to buy licenses for this stuff. You need to buy the operating system licenses for the number of hosts. And that's all too much if you've got a very small implementation and a small footprint. So this is actually something we use for our very small track care customers. Host 1 and host 2, running Red Hat on bare metal with some number of instances of cache or Apache. And for availability, we just use cache database mirroring. So they still get their HA, they get very fast failover. They get their storage inside the server because they don't need an awful lot of storage. So they've got their data separation for mirroring, they get their HA, and these guys typically aren't 24/7 operations either. So if you need to take something offline for maintenance, you can. So that's the corner case for very small. Okay, I'm going to move on to best practices. So what these are is the best practices, the simplest things I can give you in a short talk like this, the things that I think will make the most difference if you take them away, and are the ones that I'm asked about the most. So the first thing is actually, who here has logged onto the developer community, community.intersystems.com? 1, 2, 3. So like a third to half the room. So you really should. It's a place where people like you ask questions and get them answered by other people like you, or even from the InterSystems people. So there's a lot of activity there. So whether your focus is infrastructure or REST or Iris or whatever, this would be a good place just to get a discussion going. But because my focus sort of intersects with VMs and virtualization and performance and capacity planning, they're the sort of things I write about. So if you search for me or you search for capacity planning and performance index, you'll strike. So I've got this list of posts that I've written which go into what I'm going to talk about today, but in a bit more detail. So the VMware Best Practice Guide is a great place to start. It'll cover sort of the things that you really must do. So if you're moving to virtualization, have a look at that. And I'll be honest with you, there's not an awful lot difference between how you deploy a cache database and an Oracle database or a SQL Server database. Databases have certain requirements. They want low latency, they have other things. So the best practices are quite generic. If you're deploying something else, you should still have a look at that. And there's other ones, like out of the performance benchmarking I've done with the vSAN, I wrote something about hyperconverged, and I'll probably do the same when we finish our Nutanix benchmark. And of course the cache documentation. I like this idea of the hardware food groups, because even though we're virtualizing things, it's really how we interact with the hardware and how we size our VMs and the things we do there. Underneath it all, even though we're abstracted away, we're still using hardware. So there's 4 things that really you only have to worry about: memory, storage, CPU, and network. Get the balance of those right and everything will be just golden. So I'm going to skip through, as I said, the things that I'm asked, if I skip through in the right direction, the things I'm asked about. So CPU, first off, turn on hyperthreading. This is something you do at the BIOS, because there are people who argue for or against. Certainly for cache databases, you turn on hyperthreading, and that will give you a little bit of a performance boost. Right size your VMs. We'll sort of touch on that topic as we go through a few other things. This idea that I've done my capacity planning, it says I need 10 CPUs for my VM, but I've got a whole lot of space on my machine, and it'll let me sort of create a VM that's 40 wide. Should I do that? Well, the short answer is no. Make it the right size. You'll help out the scheduler, you'll help out the VM run more efficiently. And as we'll see, it has impacts in other areas as well. It's quite valid. The fantastic thing about virtualization is you can right size. Back in the day, if you bought a bare metal server, it had this many cores, and you bought it for what you expected to be doing in 5 years. With virtualization, everything's consolidated now. You get these consolidation ratios. You can stick all your different machines on there. And what that means is that you could size your VM for 3 years. If you're a bit out, you can adjust it. You can add more CPUs. You can add more memory. You can even add more storage. It's fantastic for a person like me. Back in the day, I was sweating bullets when I was speccing systems for customers. What if it's too small? We're going to be screwed. We're going to have to buy these guys a new server if we've underspecced it. So the temptation is to overspec things. Of course, that doesn't help anybody either. So size for 3 years, say. See how things go. Then you can increase, in your maintenance window. And this last one, plan for 1 virtual CPU per physical core. And this is something of a bit of a mantra for me. So what does that mean? It means if I've got a 24-core server, so 2 12-cores. So this is a picture of my labs, one of my lab systems in Sydney. VMware, the UI, will let you create a virtual CPU for every thread. Remember, this is hyperthreaded now, so a 24-core server has 48 threads. That's how hyperthreading works. If you do that, though, you're not going to get the best out of your system. You're going to run into trouble. Just take my word for it, and if you really want to, I can give you some references. I've done testing on this myself, and I've published them on the community as well, with cache. So, don't do that. If you've got a 24-core server, the largest VM you want to be creating on there is 24 cores, whether you've got hyperthreading or not. So, when I talk to customers, they go, but hyperthreading doubles the number of CPU cores. Does it? Any ideas? Well, it doubles the number of virtual CPUs I can allocate. So the reason I'm doing this now is because this is something I do get asked. Remember, you've still got a physical system under there. A core is a core, no matter what you do. Whether it's got hyperthreading or not. Just because you can create a VM with lots of threads doesn't make a difference. So the picture there shows a workload going through, so like 4 processing units and the micro execution in each processor. So the green shows 1 VM, so this is without hyperthreading on. One VM does its stuff, and then the purple VM does its stuff. But you can see the white squares in there. They're little gaps when the processor is in fact idle, while it's going off to fetch stuff from cache or from memory. So there are gaps there. So what hyperthreading does, it allows the scheduler to work in and sort of fill in, a bit like Tetris, some of those gaps. It doesn't fill them all in, but it does shorten the execution time. But it's going to shorten it maybe 10 to 30%, not double. So you've got to set your expectations in the right place. Now, if you've got a really busy database system, there's not going to be a lot of white space. In the middle of the day, your processes are still pretty flat out. But I just want to get that picture in your head. So we come back to that. When you're sizing, this is part of the reason why you do one virtual CPU per physical CPU. Because you don't suddenly get more CPUs. So one of the other things, one of the flash talks I had yesterday was around memory and so on. So the guys that came to that, this will be familiar, although this picture is an awful lot better than the one I was drawing on that pad. Around about, so back in the day, Moore's law said that we double the number of transistors on a processor every 18 months or so, and that drives up the performance and of the processor and what you can get out of it. Around 2004, that actually stopped happening. We got down to those tiny nanometers, and the way Intel kept the scaling going was actually just to start putting more cores on each processor. So that led to some other bottlenecks, and if you've done any benchmarking or tried to troubleshoot systems, as you fix one problem, you just run into whatever the next bottleneck is. So putting lots of cores on was great, but then you got bottlenecked on the CPU channels. So the way that they approached that was if you have a 2-socket server, this is your standard blade or standard rack-mounted server that you see in a data center, they usually either have 2 or 4 sockets. So a 2-socket server, if you look at it, a package of CPU and memory is a NUMA node. So it's one node. So what happens is the scheduler will try and run all its processes on this one CPU and keep the memory for those processes local by keeping them on its side of things. Now the other processor is doing the same on the other side. And it's called NUMA, non-uniform memory architecture, because if I have to access some memory that's attached to CPU 2 from a process running on CPU 1, it's slower. It's not uniform. It's non-uniform. It's a little bit slower. Between the two is a very fast interconnect, and it's something that you shouldn't worry about too much. But if you can help out the system by sizing your VMs to be the size of a NUMA node. So if you have 2 12-core processors and you can have the choice between a 14-core and a 12-core VM, it might actually run better if it can be 12 because the schedule will keep everything local. And remember, cache is an in-memory database, so anything we can do to make memory faster and better accessed is a good thing. The same goes true for your cache. The cache is all involved in this. Anytime you read off memory, it goes through cache and into the CPU. So once we go across the other side, we're going through different cache and so on. The other thing I'd point out from this picture, by the way, I didn't draw this picture. There's a guy called Frank Denneman who works at VMware. He wrote this book. Now, if you really want to nerd out, this host resources deep dive goes into all of this stuff in great detail. If you want to have a look, I'll leave it up here. So, I didn't get born with this information. I learnt it off other people as well. So. But one of the other really important things is the way the memory channels are populated. So we can see that in this picture here, we can see channel 1, 2, 3, and 4, and they've got 16 gig DIMM. So those are the memory chips that you see in a computer. If I populate the first 2 rows there, so the green row and then the brown row next to it, the memory will run at full speed. So in a modern Haswell or Broadwell, the latest or the last 2 generations of server, they have 4 channels and their memory runs at 2400 gigahertz. But if I populate the third row, it'll drop to something around 1800, so like a 20% drop in speed. So when you're configuring a system, this is why we're doing stuff, we're talking about virtualization, but how you work with your hosts can impact how things run as well. So I want to point that out. So there might be a choice between 16 gig DIMMs and 32 gig, for example. Okay. One of the other best practices is when you have a large VM, it used to be that you would say, when you create the VM, in the UI there, you can create one core per socket. So if I had 24 cores, I would in fact create 24 sockets. So I'd be pretending at the VM layer to have 24 processors, each with just one core each, instead of what it really is on the disk, which is a 24 core, one processor with 24 cores in it. Well, why is that important? It's because the way the scheduler works, it is in your operating system, and the way the scheduler works in VM can get in each other's way. How you specify a VM is how the operating system sees it. So if you go into Red Hat or Windows, you'll see the machine thinks it's got that many cores or that many processors. Now, a year or two ago, or 18 months ago, it came out that VMware started telling people you should actually look at the topology of the real server and create your VMs that way when you're creating large VMs. So I changed my best practice, and a few months ago I was in Sydney and I was working with a colleague, and we were doing some benchmark tests and sorting out some benchmark scripts. And I set up the server, our 24-core server, as it is on the left. And my colleague Tony said to me, "Hey, you're not following your own best practice." And I said, it's probably not going to make a difference. But he sort of got my interest, and really I should look. So I did set it up, and I was really surprised. The results are in that table there. I actually got like a 7% bump in performance. So component response time is how we measure the transaction times in track care. So it went from very small to even smaller, but it was 7%. CPU utilization went up. Well, of course it did, because we're doing more, and glow refs went up for the same reason. So if you have a production system that's set up in the old best practice, next maintenance window you might want to think about setting it up as the new best practices, and there's plenty of resources on the internet for that. I'll finish up with memory. Cache is an in-memory database system. We want to reserve our memory in a VM. So when a VM starts, you can actually make a reservation. You can say how much memory you want to reserve for this VM. And when you reserve it, no one else can have it. It's mine. And that's important because we don't want it paged out. We don't want other VM stuff happening. There are some caveats to this, some things you have to think about as far as your capacity planning. But this is the rule. Reserve 100% of your memory. The side effect is that when a VM starts, VMware will create a swap space for the same size as the memory, just in case it does get swapped out. Because we've reserved 100%, so all your global buffers, all your operating system, everything, however big it is, reserve that much. But the swap space won't be created. So if you had a 256 gig memory footprint in a really large VM, that won't be on disk. The swap space will be 0. So you're saving some storage as well. Yeah, Ning.
If you have a few processes swapping out and in, that's not a big deal, right? And is it worth it to reserve it 100%?
You do, and I'll tell you why soon, and it's not really a technical reason. It's when I start talking about layer 8. And I think, So Ning asked, do we really care if we get a little bit of memory swapped out? Well, I do. For storage, you want to minimize I/O. That's probably the first rule. And you do that in cache by just sizing your global buffers so that you try and get all your code tables or your working set or whatever it is your application uses all the time up in memory. And so you're reading a minimal amount off disk if you can possibly help it. That'll bring your I/Os down. We see very large hospitals doing less than 500 read IOPS, continuously during the busy time of the day, just because everything is up in memory. And so anything you can do to take the pressure off I/O is a good thing, because you don't have to worry about it as much. VMware comes with paravirtual SCSI adapters, but they're not installed by default. Now, I won't go into the nuts and bolts of this, except to put it up there and let you have a look at either my stuff on the community or just go and Google it. But essentially what you want to do is use these because they use less CPU, they're more efficient, and you can use multiples of them. Use a different adapter. So at when you define your virtual machine, you can say, I want a I/O adapter, a disk adapter for my journals, and create a journal disk underneath. And then different one for data, different one for something else. And the benefit you get from that is these all have different these all have queue depth, so you're using multiple queues as well to do your I/O. And the plan for low latency. Anybody got any ideas how I can lower the latency of my I/O?
Flash drives.
Yeah. So yes, nowadays we've reached that, I think, inflection point where if you have anything to do with specifying how the system is set up and what hardware is bought, really you should be looking at flash. At worst, tiered storage. At best, just all flash. There's plenty of vendors who will help you with that, whether it's HCI or traditional stuff. Okay, so we get on to layer 8. This is one of the things that I see at sites, and we get brought in sort of while things are going. Overcommitted resources. When we put in a vSphere cluster for track care, for example, the IT department gets this nice new shiny rack with lots of new latest generation servers and some lovely storage, and we've sized it for track care, what we expect, and then over time people just start putting other stuff on there and more stuff, and then they put let the developers run riot on there and create lots of VMs, and sooner or later we get to the point where the users are ringing up and saying, my system's going slow. How could that be? And so people look at VMstat in Red Hat or Windows Perf Monitor in Windows, and it says the system's only running at 60% CPU, the storage looks okay, I can't see any network problems. What could be causing it? Remember, the operating system can only see what it's being presented. I've had to go on site with customers because if you run pbuttons, for example, and you look at the output of VMstat, you're looking at what the guest can see, what the VM can see. Remember, the guest is running on a host with a whole bunch of other guests, and some of those guests aren't very nice. And so what can happen is your system is running at only 60% because it can only run at 60%, because somebody else is using all the CPU resources, and you can only get that many time slices. So you have to step out and look up and monitor the host as well. So if you're running pbuttons 24/7 like we recommend, so that you can look at performance problems in the rear view mirror, you're only getting half the story. I literally have had to go on site and look at the host level stuff from VMware to see that this system was smashed. It was 100%. It was no wonder the system was running slow. Okay, so here's one layer 8 solution that we've taken. For very large customers, the picture at the bottom is host 1 and host 2, and they're actually bare metal servers with a cache database mirror. So we've actually taken them out of the virtualization pool and isolated them. So there's no noisy neighbors because there are no neighbors. We're just running on bare metal. This is a special case, but when you go up to a certain size, you're going to have to be buying the same number of hosts anyway. And so this is a way to just absolutely guarantee that your tier 1 mission critical database is not going to be interrupted by anywhere else. You can still share the same storage. You can still have all your production web servers and print servers and whatever else you use running on the VMware and getting all the HA from that as well. But this is just one way to separate things out. So a question I get asked often is, can you use database mirroring on VMware, and should you? Even before I ask the question, any? Yeah, so the short answer is yes. And this is in fact the default for how we specify track care outside the US. There's no particular reason not to use cache database mirroring. The obvious question is, well, why would you use it when you've got VMware HA, you've got vMotion, you've got DRS, you've got all these other things going on at the VMware level that can do your HA for you? Well, mirroring, remember, if you've been to any of the mirroring sessions, when you've got a primary and a backup mirror, if there's a failure at the cache level or the application level, causes a cache error, your journals fill up or something, and that instance goes down, VMware doesn't know. VMware will just sit there and nothing will be happening now. But cache will know. The arbiter will be happy as well. And so what you'll be doing is you'll fail over, but you'll fail over in a matter of seconds. So you get very fast failover. If a host fails and you don't have mirroring, yes, the VMware will restart. Yes, the operating system will come up. Yes, cache will recover to a recovery point, and then you'll move forward. But all that takes time. Once again, if a host fails and you've got mirroring, you start up pretty much straight away. Or you don't start up straight away. Users connect, and they just continue working, in a matter of seconds. So this is your belt and braces approach. There is a cost. You have to have double the storage, because that's how mirroring works. We separate the data layer, and you do that in your storage array by using separate storage pools, separate shelves, however your storage array gets chopped up, but you want to keep them separate. And it's the same at the host level. You can use something called anti-affinity to make sure your two mirrors don't run on the same host, because obviously you don't want your host going down and then you've got nothing. Okay, so what is the minimum number of hosts required when using HA and cache database mirroring? Any ideas? Anyone want to guess? 4. Yeah, 4. And I'll tell you why. You really want n plus 1 plus 1, because you want to come back to full availability as soon as possible. So that's how I plan. Belt, braces, and hitching up as well. I'm going to run through quickly some benchmarks we've done with virtualized systems. I'm not going to spend a lot of time on it. I did a session in the Flash Talks on this, and I also covered this yesterday in the HCI session. But essentially we run performance and stress test and other benchmarks to understand how the systems are going to perform. And so we've been doing this on virtualized systems since, I don't know, about 2010, I think. And certainly we've been publishing results. The thing I want you to take away is that really we don't see any problem. We've certainly got the live sites out there to prove that it works. We've got benchmark results that say it works. And in fact, there's a lot of reasons to go to virtualization. In September last year, we ran a benchmark in conjunction with Intel and VMware on their hyperconverged infrastructure, which is called vSAN. It's in some ways quite similar to Nutanix, who've been doing this for a long time. So you can go and talk to those guys in the Solution Exchange if you're interested. But essentially, we talked to VMware and Intel, and we talked about what's the best setup for a database if we were going to be giving it to a customer. And the very short answer is we would go all flash. We would use the fastest storage possible at the NVMe at the caching layer, which is NVMe at the moment. And if you go to Google and you look for Intel, vSAN and InterSystems, you'll see much more in detail of the white paper. But the short story is that we saw a nice stepping up of global references. You know, most benchmarks in the past, whether we're doing Itanium back in the day, or Power, or x86, they're CPU benchmarks. You know, the storage sort of just works. Where HCI is different is, well, now the storage is part of, you know, the solution we're testing. So this is much more interesting. What's going to be more interesting is when we get beyond just the scalability and you know, performance testing is on the day 2 operation stuff. What happens if we pull a host? What happens if a disk comes out? How does this thing rebuild? You know, what impact does that have on users? And I don't have good answers for you from experience or from benchmarks. But those are the things that I'm going to have to be looking at a lot more closely so that I can inform you guys and help you, because it's a different animal than the old shared storage. So we have to figure that out. And we also did ECP, so just scale out. And remember, these are hyperconvergers, like are scale out systems. So another use case for this would be this, or in fact, you know, now Iris, InterSystems Iris database platform, or whatever. I got the words in the wrong order, I'm sure. The other thing we look at is, for a long time, we've been using a utility internally called RAN-read, or random read. And we used to use this a lot for smoke testing storage arrays during an implementation. So this utility just writes out a big database and then randomly reads 8K blocks off it. So it's just a flat-out I/O test. If you go to the developer community and just search for RAN-read, you can actually just download it off GitHub, and you can import it into Cache, and you can run it yourself. So it's a nice, handy tool. It's a good troubleshooting tool. The impressive thing about this was this and the Nutanix system that I've tested, we get fantastic IOPS because now we're using all flash and it's nice and close to where the CPUs are. So you can see 50 of that benchmark system we had, which commodity servers and the flash storage, we're getting 50,000 IOPS, but sub-millisecond latency. And as database people, what we care about is latency. How fast can we get the data? How fast can we write it out as well? You know, I'll compare that to back in the day on a spinning disk. You know, to get 50, in fact, this is the Nutanix benchmark, sorry, and 50,000 IOPS, you know, that would have taken 410K disks. You know, and I think we're using like 8 or 16 disks here. So massive differences in scalability. 8. So that's all I wanted to tell you about now. If there's any questions, I'm happy to talk about it. Otherwise, please complete the survey. We need to know if we should be doing this session or anything else you would like for the next time we have a global summit. So any questions? Yeah?
So this seems very specific to VM. Would the same kind of rules and generalizations apply to other virtualized environments? Same for Unix?
So if you're talking about Power, like IBM Power, no. They would have their own rules. I just don't deal with them because we don't have to be honest. We don't see where I am, outside the US, we don't see so much power. They would have their own best practices. Your best thing to do, though, is to look at the cache documentation and set up your AIX as that recommends. You know, there's a real element of it just works because that's been virtualized for so long. Like I said, when I do talk to the customers using Power, you know, I was in Sydney a few weeks ago talking to one, they just call them hosts, and it seems to be like not even entering their brain that they should be doing something special. Maybe they're doing stuff and they just didn't tell me, but I don't have good advice for that, I'm sorry.
You also mentioned using bare metal. What are the performance differences between bare metal versus overhead virtualization?
Yeah, for VMware, nothing really. Like, I don't account for it. Negligible, yeah. There's a koala bear here for you. I just blinded myself. Any other questions? Well, I can see I've got 33 seconds left on the clock, so I think it's time to go. Thanks, guys.